Good evening all. Today class is about various filters maintenance and its practices. So seniors may be knowing what are the filters, where it is located. For new joinees, this is our locomotive. We have mainly big three filters, that is TMB filter, MRB filter and HOG filter. And why do we need filters? Like as air is important for our survival, air is that much of important for our locomotives to run use directly. So for that we need filters. So by using filters, the filters will remove the dust which is surrounded near the track, debris and all, and it will supply clean, fresh, compressed air to the equipment fitted in our locomotives. Now first coming to TMB. TMB stands for traction motor blowers. These are very critical components which are used in our modern three-phase electric locomotives like WP5, WP7 and WG9. And this main function of these filters is to cool the traction motors. And the purpose of these filters is to for air filtration, motor protection and cooling efficiency. So that air filtration, the primary job of the TMB filter is to clean out the dust, debris, insects, sand, which enter inside when the blower is sucking the air from the atmosphere. So these filters avoid those things and give a clean air to our equipment. And that motor protection means our motors run continuously on the track, so heat is generated. So when heat is generated, the equipment tear and wear will be there. To sort out this problem, cooling air is passed on to this traction motors through our TMB filters. And cooling efficiency by giving cooled air, preventing of the motors from overheating during heavy freight and high speed, because our motors run for continuously on high speed. So for cooling that we are using these filters. So normally we have in our locomotive two TMB filters, two MRB filters and two OCB filters to cool our equipment. And these filters are made up of mainly stainless steel. And this stainless steel TMB filter is mainly consists of vertex tube. This vertex tube is the main important thing which is used in these filters, which allows air in a cyclonic form. The air rotates in a cyclonic form where the dust is collected onto the outside circumference of the vertex tube and clean air is passed into the motors. And these are fixed so rigidly to stand heavy vibrations. And these vertex tubes are made of fiber reinforced plastic. And they work along with MRB filters and OCB filters. Now maintenance and cleaning procedures. For maintaining of these filters, RDS has given a guidelines. It is SMA 286. So as per that guidelines, we are maintaining our filters in our shed. Before climbing a locomotive, removing the filters, we should ensure the OH is isolated. After that, we have to unscrew these pipes, hoses which are connected inside the body. Then the outer bolts of this filter is removed. If the filter is removed, then we can see this plenum assembly. This is a scavenger duct, and this area filter assembly is covered with this vertex tube. So once that filter is removed, dismantled, brought out to a standard place where this cleaning is done. So once this filter is dismantled and separated from the locomotive, brought on to the washing area, this outside mesh of the filter is removed. Then this is a lower assembly which is fitted inside. This is heavier part of the motor, and this is the vertex to assembly what we are seeing. This is a scavenger duct. So all these three items has to be washed separately. Before washing, air is given. Air pressure is given at a 8 to 10 kg pressure. So with that, fine dust, everything is removed. After that, we are having a jet water facility. As per IRDC guidelines, we should use 75-degree temperature hot water to remove the dirt and all. So with that washing, everything is removed. After that, a 3 kg, 2 to 3 kg air pressure is used to remove that water. We are cleaning by air also here, and again we are placing the filter in hot sun for 1 or 1.5 hours to remove that water content or moisture content. Then these filters are loaded back into the locomotive. So this is the cleaning procedure where you can see how much of dust is being removed from that filters. So this we are doing in every schedule. IA, IB, IC we are doing, and AOH also we are doing. Normally in IA, IB we don't dismantle it. Full filter assembly is removed. Same air and water pressure is given to clean the dirt, and we are refixing. In IC schedules we are dismantling fully, as I have shown you already. We are separating each and every part, and we are cleaning and refixing it. So this is what he is doing is, this is the air pressure. With air he is removing the water content from here. So once cleaning and drying is everything is over, then this filter is brought back here. He is providing, in this video you can see he is providing separately, but our practice is we assemble everything at the shop floor, it's the ground floor, then we fix it back onto the locomotive. So again, after fixing everything, these hoses have to be clamped and fixed properly for suction free filtered air. So this is what I have told, it is written here. Staff use specialized ladders for climbing up the locomotive for unscrewing all these filter bolts. Then they jet wash it. Then drying procedure is done. They dry it using a compressor air. And after cleaning and all, we check for structural damage. Any physical damage is there or not, we check it, ensure it, then we reload it. During AOH and IOH, all the rubber items are changed. It's a must change item. So the filter assembly contains FRP vertex modules which are fixed onto a single layout, and this single layout is taken for standard maintenance practice. This isolating this one I told already. Once the filter unit is on the floor, we unscrew all the peripheral bolts. For better maintenance, we can use a free choked cloth with kerosene. We can wipe all the dust accumulated on the filter assembly. Then a high pressure water jet is used to remove the clogs. Then forced air is used to remove the moisture. Then physical checking is done for any structural damages or welds. Now, if improper sealing of these filters is done or not fixed properly, then dust, contaminated dust air will enter into our locomotive and our locomotives may failure online. So, proper sealing of gaskets is ensured. Removing of that tiered gaskets are checked, and mainly EPDM gaskets are we are using for our locomotives, which stands for which gives a better life. And this is done during every schedule IAIB IC and during TOH, IOH and POH also. The cleaning procedure stands same during every schedule. Next, MRB filters. these MRP filters, like TMB filters are used for cooling of traction motors. These MRP filters are used for cooling of VC unit SR1, SR2, BUR and VCU. So the structural fitment, everything is as same as TMB filters. It also has a outer cover mesh and vertex tube assembly. These are mainly used in WP7 and WH9 locomotives to safeguard GTO thyristors, insulated bipolar transistors, and its main function is to maintain a positive pressure air inside the machine room to keep our electronic cards safely. Dust accumulation on printed circuit boards may create a short circuit and may cause a failure. So to avoid that, these filters are mainly used. And these also two MRP filters are used on the two bogies at two sides of the locomotive, and assembly and all is same as TMB filter. It is also having this vertex tube. Its maintenance practices same as TMB filters. During IA, IB, IC, UH we are doing it. And during ICs we totally dismantle it and we clean these things. This is the TMB filter, as you can see. This also has this vertex tubes. Mainly these are the areas where this dust is choked and doesn't allow clean air inside. So we use these water jet machines and high pressure air to clean our filters. And we have to ensure these welding joints, any crack or anything, otherwise we may get a booking like during running of our locomotive, unnecessary sound is observed in our locomotive. So that is because of these plates getting dislocated or damaged. So next, coming to OCB filters, these filters are like other two filters are mounted on the side wall of our locomotive body. This is mounted on the rooftop. OCB filters main purpose is designed to cool this traction converters and transformers to cool the oil. Its main purpose is when locomotive runs, it generates extreme heat during the operation. So cooling oil circulates to the traction converters and transformer assemblies. They absorb heat. So to cool that heat, these OCB filters are used. The OCB filters from roof, it draws ambient air across these radiators to cool the oil. So these OCB filters will ensure maximum airflow, which keeps electronic components safe. Like TMB MRB filters are mounted on the sidewall, which can be easily removed during every schedule for easy operation. These OCB filters are mounted on the rooftop, and it is generally cleaning is done during AOH and IOH, not during every schedule. But in every schedule, the radiator is cleaned for good performance. So this is the OCB filter which is mounted on the rooftop. So for dismantling, they unscrew all the outer bolts and the bolts which hold these filters. These two are the filters of OCB. This is the top mounting cover which holds these filters. Once this is unmounted, the filter is brought out on this trolley. Then clean air is passed from both the sides, bottom and top, and dust is removed. Then we have two gaskets. Here on the gasket is provided, and the bottom, here on and here on both sides we are providing EPDM gaskets for arresting water leakages. and to arrest clean air also. Next is HOG filters. So as you can see here, the air supply is checked. There are several fixed points given in our locomotive where the air is taken inside and drawn outside. So during those areas, we check through our anemometer the air pressure. The value given for this is for traction motor. At the end of the end shield, we check the air pressure. It should be 12 meters per second. There are some 6 locations given, and for OCB radiator also, there are some 9 positions given. At the bottom of the OCB filter, there are 9 positions where we can check air pressure. And for this HLC, at 12 locations we check, and it should be around 2.5. Behind the BC unit, we have got air sink, heat sinks where we check the airflow. This is our HOG filters. This is the outer part and this is the inner part, as you can see. And this MOF filters. These are the main basic filters which are provided in our conventional locos. Earlier, as we have seen, all those filters are three-phase filters. These filters are used in our single-phase locomotive. These filters assembled with 9 layers of um, fine small holes which are placed like what you say aligned. One is vertical side and another one is horizontal side, which allows clean air into our locomotives. Its main primary function is to defend heavy dust which are coming out from the track side, and it safeguards tap changer, high motors like R note, auxiliary motors, and these MIF filters are maintained as per an audio SMI, that is MS 289. As per MS 289, it is maintained. As you can, this is the MIF filter which is placed in our locomotives. WP4 will have 11 filters onto cab one side and 11 filters onto cab two side, so total 22. And WH7 will have 12 filters and 24 filters. In WP4, 22 and WH7, 24 filters are placed. And as you can see, these are the 9 layers of mesh which are provided inside this filter panel, which safeguards our locomotive. When locomotive is energized and the ambient is started, so air from the outside is absorbed inside. So these filters will absorb. During raining, water also will be absorbed into these filters. So these waters are collected here and it is discharged through these bottom holes. As you can see, this filter is placed here. These are holes which will drain out the water which is collected through the filter and did not allow inside the locomotive. That's it. Thank you.